When we think of algebra, what comes to our mind is a game of numbers. An alphabet, say A, say X, say Y. It can be anything. It can be N. In a moment, these numbers can be used to form an expression, an equation, which can be used to form a solution. The alphabet does not really matter. What matters is what they represent in an expression or in an equation. When I write something like this, A plus 5. This is an algebraic expression because it has no equality sign. Once there is an equality sign, this expression becomes an equation because it will be equated to something. The A in this expression is the variable, while the 5 in this expression is the number. This expression is unfinished. This placeholder variable, we said we don't know what it stands for. So this expression is incomplete until we are able to find this value of this variable A. In order to make this expression complete or to be true, the question can tell us to assume the value of A to be equal to 3. This is just telling us wherever you see A in an algebraic expression or an algebraic equation, you should substitute it with the value given to you. In this case, 3. For this to be true, this will now be A standing in place of 3 plus 5. This will now be complete to give us 8. So this variable, when we know its value, it stops becoming strange or a mystery. It becomes familiar. It now turns to something that we can solve, which is 3 plus 5. It is confusing to get A plus 5, but it is easier when we know the value of A, what A stands for in this expression, which is 3 given to us. So we can now say 3 plus 5 equal to 8. Our expression now becomes complete. The letter did not change the math. Rather, it completed the math. These expressions can come in form of addition, just like we've seen now, or in form of multiplication. If we are given an expression, say 4x, this means 4 multiplied by x. If we are told that x is equal to negative 2, our algebraic expression for x will now become 4 multiplied by negative 2. This will now be 4 multiplied by negative 2 is negative 8. The value of this expression will now become negative 8 because we are now giving the value of x, the variable, to be negative 2. Algebraic expressions also can come in form of addition and subtraction. In this case, let's look at another example. If you are given 5 minus y plus 1, the variable in this case is y. And if you are told that y should be 9, that means we should substitute the value 9 and replace y with it. Substitute y with 9. And this expression will now be complete. 9 plus 1. Because we have subtraction and addition in this expression, we'll go from left to right as our order of operation. 5 minus 9 is negative 4 plus 1. Negative 4 plus 1 will give us negative 3. How did we know? Remember our number line. This is 0. This is our starting point, 0. We'll go to the right. If we go to the right, we are increasing by 1 or by any specific number that is the same along the path. And the right-hand side should always be positive, while whatever we have on the left-hand side is negative. Negative 2, negative 3, negative 4, negative 5, negative 6. The question is telling us negative 4, which is this, plus 1. That is, move one place to the right because we are adding. If we move one place to the right, negative 3. That is how we got negative 3. Algebraic expressions also can come in form of fractions. If you are given negative 2 plus 20 divided by a variable b, we can only solve this expression where we know the value of this variable b. If they don't give us the variable b, the value of the variable b, this will become too complex or complicated for us to solve. We can just simplify this a little bit further. Negative 2 plus 20 is 18. That's the numerator over b. Therefore, we still need to know the value of this b. We can be given to take the value b to be negative 5. You now see from here, because now we now know the value of this b as negative 5. When we substitute it into this expression will become complete and we have our answer. If you substitute this, 18 divided by negative 5, this will now be negative 18 over 5. Algebraic expressions can also come in form of parentheses. We can be given 9 into x plus 4. Here we have a parenthesis, x plus 4 inside the parenthesis, multiplied by 9. When we know the value of x, say x equal to 2. And if you substitute this into this algebraic expression, x, our answer will now be 9 into 2 plus 4. Close the parenthesis. If we remember our pendants, parenthesis comes first as our order of operation. So we do whatever is inside this parenthesis first. 2 plus 4 is 6. 2 plus 4, 6. We expand this. 9 multiplied by 6, 54. We can be given an expression. Let's say 4 divided by a. If we are told to take a as negative 7, and if we substitute this negative 7 into this algebraic fraction expression, we will now have 4 divided by negative 7 plus 9. When we simplify this fraction, we can simplify the denominator first. Negative 7 plus 9 is 2. Our expression will drop to 4 over 2. When we divide this, 4 divided by 2 is 2. So the value of this, our algebraic expression, after substitution, we got 2. So the value of this, our algebraic expression, 4 divided by a plus 9. Because we are told to take the value of the variable a to become negative 7. And after substitution of a as negative 7 and simplifying the expression, we got 2. What if we are now given a fraction, an algebraic fraction expression, whereby the variable is up for x divided by 12 minus 4? If you are told to take x to become equal to 1, we'll substitute this x into this. This will now be 4 multiplied by 1 divided by 12 minus 4. This will be 4 multiplied by 1 is 4. Anything multiplied by 1 is still that same thing. Divided by 12 minus 4 is 8. If we simplify this further, we should be getting 4 into 4 is 1. 8 is 2. Therefore, the value of this expression, 4x divided by 12 minus 4, is 1 over 2. A variable also can appear more than once in an expression in algebra. Let's say you are given negative 2a plus 10, all divided by a. And if you are told to take a to become equal to negative 10, if we substitute this negative 10 as a, 2 multiplied by negative 10, when we simplify this further, we'll deal with the parentheses first. Negative 2 multiplied by negative 10 is positive 20, because negative multiplied by negative is equal to positive. We'll add 10, this 10 to it. We'll still divide by negative 10, our variable. This will now be equal to 20 plus 10 is 30 divided by negative 10. 30 divided by negative 10, our 0 will cancel 0. This will now be negative 3. So the value of this expression, negative 2a plus 10 all over a, because we know what our variable is, that is 10. So the whole story is that an expression in algebra, because it has a number and an alphabet and has no equality sign, while a variable is just a number that is yet to be spoken of. A placeholder, that alphabet that we see in algebraic equation, be it A, be it B, be it X, be it Y, bit n, whatever alphabet that we can think of. Now we now see the confusion is now cleared. If we are able to get what the variable is in any algebraic equation or expression, we can solve that equation or expression. If you enjoyed this episode, kindly click the subscription button, the notification bell, so that you'll be notified when the next episode drops. Thank you for tuning in. See you next time. See you on the next one.